Hello students, welcome back to our discussion of Chapter 3, Probability. In this video we're going to go over various counting rules. These counting rules are used to determine the total number of outcomes in each event or experiment. The typical question in this section, which is section 1 in your Chapter 3 review questions, basically it's asking how many outcomes, how many different ways can certain things occur. So you just remember that when you're doing some of these questions. So the first one is the multiplication formula. Basically we're multiplying the number of outcomes in each event. How many outcomes are possible in the following 6 examples? These examples are right from page 43. We'll go over them. So let's do some of these questions here, these examples here. So rolling 2 dice. Rolling 2 dice. How many outcomes are there? Let's get this pen. So 2 dice. So here we have the 2 dice. We have 6 outcomes on 1 dice, and we have 6 outcomes on the second dice. So here 36. Part B, rolling 3 dice. There's the space for the dice. We have 6 times 6 times 6. There's 216 different ways those 3 dice could show. Rolling 2 dice and 2 coins. There's our dice. There's our spot for the coin. We have 6 outcomes for 1 dice, 6 outcomes for the other dice, and we have 2 outcomes for the coin. So this would be, there's 72 different ways we could list or show those outcomes. Picking 1 card, we're just going to assume this is a standard deck of playing cards. So we have 52. Tossing 3 coins. 2 outcomes for the first coin, 2 outcomes for the second coin, times 2 outcomes for the third coin, multiplying those across, 8. So there's a total of 8 different ways those coins should appear. Part F here, rolling 1 dice, tossing 1 coin, and picking 1 card. Rolling 1 dice, there's our 3 spots. We have 3 different events. Rolling 1 dice, 6 outcomes, 1 coin, and picking 1 card out of 52 cards. So this equals 624. That's the multiplication rule. The repeated selection rule. This occurs if an outcome can be selected more than once. The number of possible outcomes is m to the power n. However, I simplify this when I do some of these example questions. So how many 4-digit locker combinations are possible without any repeats? So the locker combination has 4 spots. It's numbers, digits. So 0 to 9 gives us 10. Repeats, there's no repeats allowed. So we can have 10 for the first spot. Basically we're left with 9 for the second spot, 8, and then 7. And this totals 5,040. The second example here, how many 4-digit locker combinations are possible if repeats are allowed? Well, there's the 4-digit combination or possibilities. If repeats are allowed, which means you can have 0, 0, 0, 0. So you can pick 10 in each spot. Basically, there's 10,000 possibilities or outcomes. The permutation rule, the third counting rule. This refers to a number of ways in which a subset of a group of objects can be arranged in order. So Important to understand that we are arranging items in order, so there is some indication of order, preference, or rank. Those are key words as well. Here's the formula. NPR equals N, that exclamation mark is read as a factorial, over N minus R factorial. So a couple things to keep in mind with factorials. I do have some videos on factorials, so it's a good idea to watch that. But a factorial, let's just do this up here. Say we have 5 factorial. 5 factorial basically is the whole numbers going down from 5 all the way down to 1. 20 times 6 is 120. So this adds up or totals 120. So 5 factorial equals 120. This point down here where it says 0 factorial equals 1, oops, just keep that in mind. If 0 factorial didn't equal 1, then none of this stuff exists. So if R does equal N, the formula can be simplified to N factorial. So a permutation is we're taking a small number of things from a larger number of things. So N will always be equal the total number, and R equals the number of objects we are selecting. So let's look at an example. This example is on page 44. There are 4 students. How many ways can they be selected as class president and class vice president? So obviously order is important because it's saying something about the order or the preference. Right in here, they're listed as class president or class vice president. We have 4 students. We are selecting 2 of them. So if you are chosen as class president or class vice president, those are different. So let's quickly list the possibilities. We could have, say, just using the letters A through D, we could have student A president, student B vice president. We can't have student A and A, you can't be both, but we could have A with C and then A with D. We could also have student B as president and student A as vice president. So A and B and A are different. B could also be president of C, and B could also be president with D. Student C could be president with vice presidents in that order. Student D could also be president. And there is a total number. 3, 6, 9, 12. So we know that the answer, there's 12 different ways we could choose a class president and class vice president out of a group of 4 students. So let's apply that formula we saw back here, NPR, to this work here. So I'm just going to go here. Let's clean this up. Clear canvas. So NPR. NPR, N factorial over the difference between N and R factorial. So this will be written as 4P2 would be 4 factorial. Remember, N is always the larger number. We're choosing a subset out of that big number, and then the difference of 4 minus 2 factorial. So 4 factorial, 4 times 3 times 2 times 1. 4 minus 2 is 2. 2 factorial is 2 times 1. And basically we can cross those out, including the 2, and we are left with 12 as our answer. Oops, let's go back to our PowerPoint. Let's do this one. How many ways can 3 students in a class of 10 be selected as class president, class vice president, and class treasurer? So there's something about order or preference here. We are not going to list these out because this would take too much time. So we're going to use the formula. Sorry, there we go. So we have 10p3. So we have 10 factorial over 10 minus 3 factorial. So we got 10 factorial is 10 times 9 times 8 times 7 factorial. I'm going to leave that as a factorial because the bottom, 10 minus 3, is 7 factorial. And we should be able to cross out all of that. So 10 times 9 times 7 is 720. Definitely didn't want to list out all those outcomes. Remember to look at the video on factorials. I give you some hints and tips about how to calculate factorials and what are some of the limitations we can do with factorials. A combination rule, very similar to a permutation. Look at the formula NCR instead of NPR. But the difference here is order is not important. And the other difference here is we have this at the bottom as well. So example on page 45, we are selecting 2 students from a group of 4 for a special project. Nothing in this question specifies order, preference, or rank, so that's a good indication that it's not a permutation. That's the difference between combinations and permutations. So let's list the possibilities. Our possibilities would be student A is chosen with student B, student A with C, and student A with D. Student B with A is the same. It doesn't matter if you're chosen first or chosen second. And basically what we're left here is student C with D. Student D has been chosen 3 times with A, B, and C, so they are all within this mix. So let's look at how the formula would work. Let's jot that up here. 4C2 would equal 4 factorial divided by 2 factorial, and then also divided by the difference, factorial. So 4 factorial, 4 times 3 times 2 times 1, 2 factorial times 1, and then 4 minus 2 factorial, another 2. So 4 times 3 times 2 is 24. 24 divided by 4 equals 6. So that is our answer, and we see that here we have 6 outcomes. So let's do this example. How many ways can 3 students in a class of 10 be selected to go on a special field trip? So nothing in this question specifies order, preference, or rank. So we know that it's not a permutation. So we have 10C3. 10 factorial divided by 3 factorial over 10 minus 3 factorial. So if we do the math for this, we're going to have on the top, we're going to have 10 times 9 times 8 times 7 factorial. I'm going to leave that 7 factorial up there because 10 minus 3 is 7 factorial. So these last little bits will cancel out. 3 factorial, 3 times 2 times 1. So the top equals 720. The bottom equals 6. So there is a total of 120 different ways a group of 3 can be randomly selected from a larger group of 10.